the time history loading on the cantilever beam. The length of the model is the 20 meter, and I will use the 50 centimeter by 50 centimeter cross-section area for the beam. And the time history of force is like this. The total time is 20 seconds, and the maximum force is 2 Newton at 10 seconds, and it is the triangular shape like this. So let's start the C program, and let's create the model by clicking create part. I will use the 2D planar, deformable, and wire, and click continue. The wire is start from 0.0 and end at the 20.0, and press ESC button and click done. The next part is the property. Let's create the material. I will use the steel material, and only elastic part will be considered. So I will use 210 gigapascal for the Young's modulus, and 0.25 is used for the Poisson's ratio. And let's create section, and select beam, and click continue. On here we need to create the profile. It is for the cross-sectional area of beam, and you can select rectangular, and you can set the dimension, the length of the cross-sectional area. It is the 50 centimeter for both sides, so it will be 0.5 for the meter unit, and click OK. And you can see on the beam section edit window there is profile 1, and steel is selected for material, and you can click continue. And then click assign section and select the model and click done. And you can see there is a section on. It is just before we made, and you can click OK. And because of this structure is for beam, so we need to assign beam section orientation. And you can select the beam and click done, and you can use the default value for the direction, and click OK, and click done. And next part is the assembly. Click instant part, and you can see there is dependent, and you can select dependent and click OK. And next part is the step. Click create step, and we will do the static analysis, and click continue. And let's put into the time period for the 30, and increment. For the incrementation we can use automatic or fixed, but let's try to use fixed at this time. I will use the time step for 0.1 seconds, and the maximum number of increments will be 10,000, 1,000, sorry. And I will use the the total simulation time is 30 seconds and the time step is 0.1 seconds, and the maximum number of increments is the 1000, and you can click OK. Next part is the road. The left hand side is fixed, so you can select the mechanical and displacement rotation and click continue, and select the left end point and click done. Because it is fixed, so you can check all of them and then click OK. And let's apply the road. At the free end, you can select mechanical concentrated force and click continue, and select the free end, it is right hand side, and click done. And you can see this window, and the load is applied to the Y direction, so the first one will be 0 and first will be -1. So we need to set the amplitude to make the triangular load. So click the create amplitude, and let's select the equally spaced and click continue, and the fixed interval will be 10 and it starts from 0, 2 Newton at 10, and if you press enter you can see 20, it will be 0, and at 30 it will be 0. So our total simulation time was the 30 seconds. So it is each time step and amplitude is linear, has the linear relationship. So this means this input means the load amplitude is changed from 0 to 2 Newton and 2 Newton to 0 Newton at 20 seconds, and it will be 0 at 30 seconds. So this amplitude imply that data. So you can click OK. On here we create the amplitude 1, so you need to select amplitude 1 and then click OK. So you can see the force is applied at the free end. And next part is the mesh. So select the part and click the seed edges and select the model and click done. I will seed by number, and let's put in 20 for that, and click OK. You can see the seed and click done, and mesh part, click yes, and assign element type, and select the model, click done. On here you need to select the beam for on the family, so you can click OK and click done. Everything is done, so let's submit the job on the Abaqus. You can open the job manager and create job, and I will use the default name for job, and you can click OK, and then you can click submit. OK, And let's monitor the process. So it is running. So this is for the total time, and it is the 16.3 seconds and 20.5 seconds. Running, and it is done. And it is, and we can see the results by clicking results. And if you click this one, you can see the stress value. And let's monitor the displacement at free end. And you can see the displacement data at the tool XY data measure. And you can click create and then select field output and click continue. And select the unique nodal at the position, and select the amplitude for y direction, and then select the node and click done. You can see one node selected, and let's plot the results. So you can see the displacement data. It is deformed to the negative y direction. It is the negative because the force is the negative, and it is the go to 0 at 20 seconds. So you can see the time history displacement results in here. Thank you for listening to this tutorial, and see you later. Bye.